Hi guys, let's do lesson 2-2, solving two-step equations. This is pretty much the same thing as the last chapter, except now you're going to have two steps. So the objective here is to solve two-step equations in one variable. Alright, if you remember the getting ready box from the last chapter, it's that same game. It says diagram shows the amount of money that each player starts with in a video game. To be fair, each player should have the same amount of money. So that means we definitely need an equal sign, and so we're going to be making an equation. If each chest contains the same amount of money, how much money must be in each chest? How do you know? So last time we just had one chest. Well, now let's just say X represents how much money's in the chest. So let me erase this so we can put that. X equals money in chest. So this time, if we have three chests, we have 3x plus 6 coins equals, let's see, 10, 15, 16, 17, 18, 19, 20, 21, 22, 24, 26, 28, 30. I believe the other side's equal to 30. So here's it says how much money could be in each chest. Now what you could do is guess and check, but let me just show you how we're going to solve these two-step equations. So some people like to draw a line down the middle so that they know whatever you do to one side you have to do to the other. But in this case, if we're trying to solve for x, you always want to do the add or subtract piece first, and I'll show you why later. It doesn't matter, it just makes it so we don't have as many fractions. So if we have plus 6, we want to subtract 6 from both sides. So then we have 3x equals, and 36 minus 6 would be 24, and then we have a one-step equation. We're going to divide both sides by 3, and x equals 8. So there must be 8 coins in each of those chests. And that right there is how you solve a two-step equation. Okay, so problem 1, let's do another. What's the solution of, now we have 2x plus 3 equals 15. So draw the line if you want to. It may help more as these get more complicated, but you don't have to draw the line if you don't want to. But definitely figure out where the variable is, and that's the piece you want to do last. So the first thing we're going to do is subtract 3 from both sides, and 3 minus 3 would be 0. So we have 2x equals, and then 15 minus 3 would be 12. And then we want to finish it out, divide both sides by 2, and we have x equals 6. Let me just show you. If we do this, 2x plus 3 equals 15. And I'm not sure how this is going to work out, but you'll see right away how messy it gets. If we decide that, here's the variable, if we want to go through and divide everything by 2 right away to get rid of the 2x, we have to divide this by 2, this by 2, and this by 2. So the 2 over 2 cancels out, and that's not so bad. So we have x plus, then we have 3 over 2 equals 15 over 2. And then you would have to subtract 3 over 2 from both sides. And we would have x equals, now 15 over 2 minus 3 over 2 would be 12 over 2, and that would equal 6. So you get the same answer. We actually got lucky with this one because the fractions weren't so bad, but it's just so you don't have to worry about working with fractions. And a lot of times people will just divide this by 2 and this by 2 and not divide the middle piece by 2, and then they're doing it wrong. So in order to kind of get around that problem, we always just say do the piece that's added or subtracted first and then do the divide part, because if you look right here, we only have two terms. We have the 2x and the 12, so those are the only things that need divided by 2. Alright, and we have, what is the solution of 5 equals t over 2 minus 3. So again, find your variable, it's t. So we always want to do the add or subtract piece first. So in this problem, we're going to have to add 3 to both sides. So we have 5 plus 3, this side is going to be 8, and then this side is still going to be t over 2. Now if we have t divided by 2, the opposite of division is multiplication. So we're going to multiply both sides by 2, and we have 16 equals t. And that's your answer for got it number 1. 16 equals t, or it really doesn't matter, t equals 16. Whichever way you put that in, it's the same thing. But I don't know, a lot of people like to have the variable on the left side, but it doesn't matter. They're both the same answer. Okay, problem number 2. So again, we're going to be writing a lot of equations from word problems. So it says You're making a bulletin board to advertise community service opportunities in your town. You plan to use half a sheet of construction paper for each ad. Anytime you get this word each, you probably have a feeling that that's going to be your variable, but not always, so keep reading. You need 5 sheets of construction paper for the title banner. You have 18 sheets of construction paper. How many ads can you make? So again, whatever the question is asking, how many ads can you make, you want your variable to be ads because that's what you need to figure out. So we'll say A stands for ads. Okay, so read the problem again. You plan to use half a sheet of construction paper for each ad. So that's going to be 1/2. That's going to be 1/2 A. So half a sheet of construction paper for each ad. Then you also need 5 sheets of paper for the title banner. So we need to add on 5 sheets for the title banner, and you have 18 sheets total. Oh, so never mind here. So that's going to equal 18. One thing that we'll do more when these equations get harder is we'll talk about this, that the total, this is kind of like a general form, total equals how you get the total. I mean, right now our equations aren't so bad, but if you see, that's what we did here. The total was 18, and then the other side is how you come up with the total. So how did you come up with 18? Now, how many ads can you make? We have to solve this for A. So first we want to subtract 5 from both sides. So we have 1/2 A equals 18 minus 5 would be 13. And now 1/2 A is the same as A over 2. So you can either divide both sides by 1/2, but if it kind of looks to me like we're dividing by 2, so I'm just going to multiply both sides by 2, because 2 times 1/2 would just be 1 anyways. Those cancel out, and we have A equals 26 ads. Okay, so with 18 sheets of construction paper, you can make 26 ads. Got it, number 2. It says, suppose you use 1/4 of a sheet for each ad and 4 full sheets for the title banner in problem 2. How many ads can you make? So again, how many ads? So we want to say A is our variable. A stands for ads. And reread the problem. Suppose you use 1/4 of a sheet for each ad. So 1/4 would be 1/4 for each ad. And this time you only need 4 full sheets for the title banner. So plus 4. And we still have 18 sheets of paper. Okay, how many ads could we make this time? And people do this all the time. It's like, it's a process. Well, maybe 26 ads wasn't enough. So if I change and I make each ad 1/4 of a sheet of paper and I use a little less for the title banner, you'll see now maybe we can make a couple more ads. And so this is what people do for their jobs. They make these equations and they make these situations. So let's see. Let's solve this for A. Subtract 4 from both sides, and we get 1/4 A equals 14. And then we have, if we have 1/4 A, we want to multiply both sides by 4. Multiply both sides by 4, and we get A equals 56 ads. So if we shrink down how much we use for each ad, if we go from 1/2 to 1/4, and we use less for the title banner, now we can make 56 ads and 26 ads. And if that's still not enough, then we would rework and make a new equation. Alright, problem 3, solving with 2 terms in the numerator. So what is the solution of, now these, it's x minus 7 over 3 equals negative 12. For some reason these always seem to, people think these are way more complicated than they have to be, but if you can get rid of the fraction right off the bat, so remember from order of operations, this fraction bar is a grouping symbol. So you have the whole top and you have the whole bottom. If I multiply this whole thing by 3, and then this whole side by 3, the 3 and the 3 will cancel out. So I just completely eliminated the bottom, so I pretty much completely eliminated the fraction. So on the left side, all I have left is x minus 7, and over here I have negative 36. And then it's just a one-step equation, and you just need to add 7 to both sides. And negative 36 plus 7, that's going to equal negative 29. Okay, so the first thing when you have equations like this that has a fraction bar in it, multiply by whatever the denominator is right away, to eliminate the denominator, and then just solve the one-step equation. As we get more into this, they'll be like two-step equations, but get rid of the denominator first. It will make it much easier. Okay, got it, number 2. So we have 6 equals x minus 2 on the top and 4 on the bottom. So to get rid of the fraction, let's multiply both sides by 4, and the 4 cancel out. So on the left I have 24, and on the right I have x minus 2. And then to isolate the variable, to solve for x, you want to add 2 to both sides, and you get x equals 26. Okay, not so bad. Part B, it says, write the right side of the equation in part A as the difference of two fractions. So I rewrote part A. It was 6 equals x minus 2 over 4. Remember when we did the distributive property with fraction bars like this? We could write this as 6 equals, we could do x minus 2, hold on one sec. That wasn't right. We can do, it's going to be 6 equals x over 4 minus 2 over 4. Okay, we just did like the distributive property, and we did it over the fraction bar. So if we solve this, so let's simplify this. This is x equals x over 4 minus 2 over 4 would be 1/2. Okay, this is just the other way. Instead of multiplying both sides by 4, which is definitely easier, now if we go to solve this, well, let's do the add or subtract piece first. So let's add 1/2 to both sides. So now we have 6 1/2 equals x over 4. And now if we multiply both sides by 4, 6 1/2 times 4 is still going to be the same answer. It's still going to be 26, but it took us a lot more work to get to that. I think the fractions is a lot harder. So it says, did you find the equation in part A or the rewritten equation that we just did easier to solve? I would say that this part was definitely harder to solve. So again, like, there's two different ways to do it. You could mathematically break up the fraction, but if you just multiply by 4 right away, it just makes the equations a lot easier to solve. And problem 4, again, that deductive reasoning, that's just when you have to state each step. So problem 4 says, what's the solution of, and it's negative t plus 8 equals 3, and it says justify each step. That's not such a big deal. I'm not really going to make you on your test. If you look at problem 4 in your book, it says you write down the original equation, and then you use the subtraction problem of equality, and then use the multiplication property of -1. I mean, I'm more concentrating on right now if you know how to solve the problem, and when we get into like more complicated stuff, I'll make sure that you can write out all your reasons. But for now, we're not even going to do problem 4 because I just want you to be able to solve each equation. So that's the end of lesson 2-2.